Properties of a wave. In this video and the next, we are going to talk about two important properties of a wave, and these two properties have great relevance to audio production. These two properties are, number one, amplitude, and number two, frequency. Or wave length. We're going to talk about these two properties in this video and the next. I'm going to ask you a simple question. What do you think will happen if we pluck this string? That's correct. It will start wiggling and vibrating and it will produce sound. Okay? Another question. What will happen if you pluck the string very, very softly? Okay? Yes. It will still wiggle and vibrate. It will still produce sound. But the sound that it will produce will not be very loud because you pluck it very soft. If you pluck the string hard, it will produce a louder sound. If you pluck the string soft, it will produce a not so loud sound. And what will happen to the vibration? If you pluck the string soft, it will vibrate, but the vibration will be very small, which means that the string's displacement from equilibrium will not be much. And if you pluck the string hard with more force, it will produce more sound and it will vibrate more, which means that it will go farther away from the equilibrium. Now, having said that, let's have a look at this. It's pretty cool. All right. Now see what happens here. What actually happens is the change of amplitude. In the first part of this video, the vibration was more. Okay, the string was vibrating and it was moving farther from equilibrium. As it was moving farther from the equilibrium, the graph that was plotted had more variations, more difference from the peak, more difference between the peak and the trough. But when the string is plucked soft, it still is vibrating, but it's not going that much farther from the equilibrium. As a result, the distance between peaks and troughs, as you already know from the last video, that peak represents one side of the vibration and trough represents the other side. So when the string is vibrating with less force, the distance between peaks and trough, that reduced. We call this thing amplitude. This phenomena is called amplitude. Okay, so what is amplitude? Amplitude is the maximum displacement of the energy from the equilibrium point. Okay, so let me just get rid of this for a while. Let's get back this graph. Okay, now what is amplitude? Amplitude is the maximum displacement of the energy. Now it means that if you take either on the peak or on the trough, if you take the farthest point from the equilibrium, now how far it is going maximum from the equilibrium line. Now this is the equilibrium line right here. How far the wave energy is going away from the equilibrium. This is the farthest point. If I take this particular peak, this is the farthest point, isn't it? So how far that is going? We take that point and then we take the distance of that point. Okay, so if I say this is the farthest point, and if we create a line, a straight line, okay, now this line, this distance is known as the amplitude. Okay, or if we take the lowest point on the trough, this is the lowest point, and if we draw a line from the lowest point till the equilibrium, this distance is called the amplitude. Okay, and what we learned about the amplitude directly relates to the power in the wave, the energy in the wave, and it's the direct result of the loudness of sound. So first of all, let's take another color. Okay, so this distance from the peak to the equilibrium is called amplitude. Okay, now what is amplitude? Amplitude is the maximum displacement of energy from the equilibrium. So amplitude is the maximum displacement okay. Also remember that amplitude is the loudness of sound. Amplitude is the loudness, which means higher the amplitude, louder will be the sound. Or if you look at it the other way, the sounds which are louder produces the waveform with higher amplitude. The sounds which are softer produce the waveform with lower amplitude. Now let's make this a little bit more interesting, and let's actually see this amplitude thingy in action. All right. Now here is a waveform of Pink Floyd song. Now, by the way, one of my favorite bands is Pink Floyd, so you'll actually hear a lot of Pink Floyd with me. Right, so this is a small part from Shine On You Crazy Diamond. Let's hear it. Yeah. Yeah. All right. Good. Right? You liked it? Oh, I love it. All right. Now let me show you another thing. Oh, what is this? Actually, it's the same waveform. Okay? Only with a higher amplitude. Let's see how it sounds. Yeah. Okay. So it's the same music. The only difference is this is louder. Now, what you see in front of you is the waveform of that music. Okay. By the way, if you are wondering that why this waveform is so weird, don't worry about it right now. Okay. Actually, think of this waveform in terms of amplitude right now and see how far the energy is going. Now here's our equilibrium line. Right here is our equilibrium line, as you can see. Okay, this is our equilibrium line, and from this equilibrium line it's going either this way up or it's going down, and how far it is going, that's the amplitude. And obviously, clearly, this waveform has much higher amplitude than this waveform. As a result, the sound that we hear from this is much softer. It's not as loud. You can compare. All right. Okay, hope it's clear. Okay, so amplitude is actually the loudness. Okay, amplitude represents loudness. Another thing that it's a good idea to mention it at this point is that how do we measure the loudness of sound? We've got different units of measurement for different situations. For example, when you have to measure the distance between 2 points, you use units like centimeters, inches, kilometers, and so on. When you have to measure the mass of something, you use kilograms or pounds or ounces and so on. If you have to measure the loudness of sound, how loud a sound is or how much power that sound carries, what is the measurement unit? The measurement unit for loudness of sound is called the decibel. D-E-C-I-B-E-L, decibel. Okay, and in short, we write it as B, small d and capital B. Now again, this is a very, very important thing to remember, because we will be dealing a lot with decibels when we work on digital audio. So decibels is the unit of measurement that we use to measure the loudness of sound. The natural sounds that we hear around us, they are usually, not always, but usually measured in a unit which is known as dBSPL. Yeah, let me get rid of this, and let's have a little more space. Okay, so natural sounds. Okay, a key point to remember here: natural sounds are usually measured using dB, which we know now what it is, decibel, SPL, and SPL stands for, what is SPL? SPL is sound pressure level. Okay, so this is what SPL means, sound pressure level. Okay, so when we are talking about natural sounds, when we want to measure the loudness of natural sounds, we use the measurement unit that is known as dBSPL. Now, why it is important to remember is because when you are dealing with digital audio, then you don't use dBSPL, you use another scale of decibels that is called dBFS or dB full scale. But let's not worry about it at this moment. We will be talking about it later on when we get to that point. In the next video, we are going to talk about the next important property of the sound, which is called the frequency.